Welcome to Radio Fixer's channel. Subscribe for upcoming videos. Not sure if this radio is fixable since it was damaged in an electrical fire. But you know me, I don't give up that easy, right? I actually enjoyed the challenge, believe it or not. So stay tuned to see if this restoration is possible or not. Really, my goal is to create these videos so a brand new person can use the information and be able to get into the hobby. It is really a wonderful hobby and very rewarding to bring back something that totally dead back to life and sing again. I highly recommend watching the earlier videos in this series. In those episodes, we disassemble the radio, inspect the electrical fire damage, document and identify parts on the schematics, replace paper capacitor and out-of-tolerance resistors, repair the multi-section electrolytic capacitor, and install new polarized power cord. Let's get started. Let's open this up to show you what's inside here. There's just one screw here. It's a pretty short screw. Just lift it up like that and pull it out. You see, that is Selenium rectifier. My understanding, this always fails, so it's best to replace that. I'm going to replace that with a diode as well as a resistor to be able to get some type of rating like this. Since the schematic does not show tube voltage, so I have to start using different size of resistor until I feel comfortable with the amount of electricity we get here. Let's see what's the best way to handle this. But again, if you have something like this, you got to replace it. This is the first radio that I'm working on that it has Selenium rectifier. So let's take it out. Seems like there's just one screw here in the front. My understanding is the reason they installed this to get the DC voltage, because when the AC come in, they want to transfer it to DC, and that's what they used to use. We're going to use, the diode, which will do the same thing. But again, you have to add resistors. Yeah, 2 wires comes inside, as I can see underneath. Okay, this is out. Was soldered here and also here. The black wire was here, the white one here. And this is very interesting. Don't know if you can see it or not. Here they mark it plus. See that? So this should be the positive side. Now let's talk about some safety issue. You're dealing with electricity. It's very dangerous. It can kill you. So be very careful, please. I need a few equipment that you can purchase it in Amazon. First one, you must have isolated transformer to keep you safe when you're working in the antique radios. And also with the variac, you can actually adjust the amount of electricity comes inside the radio. And this one, the dim bulb tester, you can actually build this yourself. You can Google it. There's tons of information out there. This is the setup I'm using on my workbench. Please make sure you know to use this equipment to keep you safe. Alright, everything's set up for the test. I always hook up the radio under the test to oscillation transformer as well as variac. And that is pretty important thing, as I mentioned earlier. I haven't started this one yet. This is original Selenium rectifier that it came with this radio. It still is working. It's best to replace this since they're getting pretty old. It might cause some type of issue down the road. So meanwhile I'm doing all this work, I'm going to also replace it with a diode as well as, drop-in resistor. But to find out what type of resistor I need, first I need to measure the tube 3V4 pen 1 and 7. I already set this multimeter, and the red is hooked up to pen 7 and the black is to pen 1. So before I get started, I make sure nothing touching anything, all the wires, not touching anything that I'm using this test lead. See, the speaker is hooked up, the antenna is hooked up, and also the Selenium rectifier is hooked up. So I'm going to start this, put it on DC. I'm going to start now. The variac is about 122 volt. It comes inside the radio. We're going to watch that. Darn, I can't believe this. After all this work, is not working. Okay, I think next what I'm going to do, I'm going to test every tube, measure the voltages in each pen. I'm going to document that. Alright, I sent the email to Don. He has his own channel. This guy is awesome. He got back with me. He suggests a few different things that I need to do. And again, Don, thank you so much for doing that. I keep testing it, and finally, I remember I did not test the tubes in my tube tester. I forgot to do that, believe it or not. So I start testing them, and I noticed 2 vacuum tubes, they're not working. They're awful condition. I look through the inventory of my tubes, and I don't have a couple of them. So I went on eBay and started searching. I found antique radio salvage that he has some tubes with very reasonable price. He was selling them. His name is Ken. So he sent me a message. I told him, hey, I have my own channel here, and if you have some vacuum tubes, I would be glad to buy it from you. And I told him, if the vacuum tubes is good after testing them, I will be glad to promote his eBay business on my video. So he sent me some of the tubes. There's 6 of them. Usually I buy, extra one just to have them. So I really need 3, but I bought 6. This is Ken Antique Radio Salvage. I'm going to put the information here in the video for you, so you can check his inventory as well. Let's look at through the package. You see, he packed it in pretty well. That's very good. So I'm going to test these tubes on the tube tester to see how it's performing. Alright, let's test these tubes. I set this tube tester is warm up about maybe 10 minutes or so. The manual here is actually telling me, how to set this up. Already set everything up according to the tube 1U5. The filament setup, everything is here. It's telling me how to set it up. So let's test it. There is a 2 stage in this tube that I have to test. These are the 2 tubes that he sent me. Let me test them. I didn't really mind to use the used tube because majority of them, they're in great condition. Sometimes the pens are dirty. I need to see if they need to be cleaned or not. This one, it seems like it's fine. I'm going to wait a couple of seconds for the tube warm up to give me a good reading. That shows about 80. It still is a good condition. And he told me, he says he's going to send me a good range, anything over 80. And I'm fine with that. So we're going to test the other one. These prices are very reasonable, to be honest with you. I'm going to put the second one here. I wait a few minutes for this warm up. Alright, this is a little over 100. Again, as you see, it shows it's good. Alright, now we're going to do second test in both tubes. I need to reset here. 610. So this tube is in very good condition. And let's test the other one. Again, this one is 100 as well. I mean, for $2 per tube, I think that's a great deal really. Alright, I cannot believe that I forgot to test the tubes. I already installed those tubes, replaced it with a bad one, of course. Now let's turn on the radio to see if it's going to perform or not. I hope it does. Oh my gosh, I can't believe this thing is working. That's awesome. I'm going to turn it down a little bit. As you see here is 1.63 DC, of course. So that is how it's set up with this Selenium rectifier. Of course, you can check this online as well, but a book like this, 3V4, it shows the filament voltage is 2.8. So that's what I'm looking at, between 2.8 in series and 1.4 in parallel. These are the two products that I'm going to use to test how much heat this radio is creating, especially since I'm planning to remove the Selenium rectifier. Anything I'm going to put there as a resistor, I need to make sure that it can accept the heat, since you know the electricity creates too much heat in those resistors. With Selenium rectifier, you know the way they design it, it absorbs majority of those heat and transfer it, of course, to the chassis the way this radio was. So I cannot use just a regular resistor. I have to buy certain type of resistor that it can handle heat. But before doing that, I have to test it. I can use this right here, this multimeter. Again, if you haven't watched the video I made about this multimeter, check it out. It's very good multimeter. I'm pretty happy with that. Under $30 or so. You know, it does a bunch of things. There's an attachment like this that it actually going to show me how much heat that part generate. Or you can use one of these things, you know, like with a laser. But this is going to be more accurate, to be honest with you, because you're going to hook it up directly to the part. With this one is good, but I will show you down the road the result on both of them. Then you may decide which one is best for you. Alright, I set this radio up. It is working. To turn it down. I set up the timer here. I left the radio on. This is just to show you what my plans are. I want to let the radio run for a while. So there's a two area that I like to measure the temperature before changing this Selenium rectifier. So one area is the resistor is right there. There's a 47 also here. Then when I put the new resistor and diode, I'm going to also test the temperature as well. Alright, you see it's about 17 minutes. The radio is on, running. Let's test it. Now that resistor, 47 ohm resistor, is about 88 degrees to 90 degrees, that resistor. Now let's test it here. About 95 Fahrenheit. Now I'm going to turn everything's off. I'm going to hook up the diode as well as a new resistor. I'm going to let the radio run for that amount of time, almost 20 minutes or so, and we test it as well. Alright? Alright, I already installed the diode right here. And now what I need to do, find out what type of resistor I need so this radio can actually work. What I did, I used several different 2-watt resistor, and unfortunately after a few seconds it burned out. You see that? It's supposed to be like this. You see, it burned out. So 2-watt resistor did not work over there for that resistor. So next what I did, I select bunch of resistors. You know, these are resistors. These are about 10-watt resistors, as you see, different size. Of course, I hooked up my multimeter to tube 3V4, as we discussed earlier, and start reading the voltages. Depends of what type of resistor I'm using. Using those alligator clip, it makes the job much easier. I suggest to do this when you want to change from one resistor to other resistor. Turn off the radio, turn it off totally, then disconnect it, put it in next resistor. Since these tubes are very sensitive, they're about 1 volt, and the 3V4 I believe is about 2.8 volt or something like that. By taking that out, you might burn out the tubes. That's the process I took to see what type of resistor I need. I tried 5 watt and they were getting very hot. 7 watt still was hot. 10 watt more stabilized. Of course, 25 watts, it will work very well, but the problem with all these resistors are they're too large. There's not enough space under the chassis, and I don't want to put anything else under the chassis that it create heat. I have to find a resistor that actually fits right here. I'm going to measure the space where Selenium rectifier was to see if I can find any power resistor that it fit there. What I did, I document all the resistors that I had to see the voltages. Of course, this is for the tube 3V4, that's pin and 7, which is a filament pins. So I hooked up my multimeter to those pins. Of course, with original Selenium rectifier, it shows 1.63 volt. Of course, we don't know if that rectifier, still is in good condition or not, but I'm going to stay around this voltage because the radio is working with these voltages. So here, I add the diode and resistor. So these are the type of the resistor I'm looking for. It should be 10 watts or over, or 25 watts. And for 100 ohm, was 2.56. This is very high, because this tube can handle 2.8. So we don't want to run it that high. That's my assumption. So I start testing all of them. As you see, I put a chart here. And around 350 to 400 is going to be very close to what I have over there. Of course, 400 is pretty close as well. So I went online and I saw a bunch of power resistors, that I can order. Like this is a 400. I want to order a few different size, nothing more than 400, because when I tested with above 400, the radio was not working. And to see what the results are. All right. Alright, as you see, I already put the diode right there. You see right there. I'm not touching it. I'm just showing you that's where it is. And this is a resistor that I'm using. I ordered some of these resistors from Amazon. There come 5 of them in the bag. I put it right here. I bypassed the 47 ohm resistor by putting this wire. No, of course I'm going to wait until 20 minutes, but let's just check to see what's going on. First I'm going to check the right here. This is the diode. About 10 minutes, that's how hot it is. See that? It's about 76 Fahrenheit. Now let's test this resistor. Now this resistor is metal. I'm going to measure here, also on the side where it's not metal. You see that? It's like a rubber thing. I'm also going to measure that. It might be hard to show you, but let's see. We're going to test this. This is just a metal surface, which sometimes the metal surface might not be accurate. So I'm going to read the side. See where the rubber part is about 80 degrees to 81 degrees. Of course, I'm going to wait 20 minutes to do the same test again, like what I did with the other setup. Hopefully this makes sense what I'm trying to show you. Since I'm removing this, even it works very well, but it's a good idea to replace this, because you don't want to cause issue or catch in a fire, and usually when they go bad they smell so bad. That's my understanding. Again, this is my first time I'm working in the type of radio that you remove this from the radio, and that's why I'm doing all these tests, because I want to make sure this radio is going to be safe. Right now I'm reading the temperature. I hooked up right here, which will show me accurate information because it's hooked up directly to that part. And you see that's how much heat is creating, 180 degrees Fahrenheit. So this is going to be another method you can use. Sometimes using this is going to be a little harder. Alright, I removed everything here. This hole is too small. I need to make a larger hole here to be able to put that resistor here. So I made this hole a little larger, as you can see. I also put another hole here as well. Since this radio gets so hot, I didn't want to run both wires from the same hole. So this is the tool I used, for the large one, of course. For the small one I use a regular drill bit. So you already add that in the bottom where they're going to hook up to the diode. Alright, this is installed. As I was sharing it, that's why I put two holes. You see that? I didn't want to put both of these wires come around here and go through this hole and touch this resistor, because this resistor is going to get so hot underneath. I don't know if you can see it or not. I removed that 47 ohm resistor. I'm going to show you how bad it was. Do you see where I put the diode? This is the line cord. It comes here, it goes to the diode. From diode goes to the resistor. Then from resistor, this is the line, this yellow line, it come back and solder right here. See where the hole is? Right, the yellow line is from other side of resistor, is soldered right here. Here used to be a 47 ohm resistor. Let me show you. I never saw a resistor like this. See, it's like a cloth cover. As you can tell, it's all burned out. See, all burned out. That's why I removed it. I don't need this 47 ohm resistor. The other resistor will handle it. I'm going to put the cover back here. So when I put the top in, when I close it, it does not hit the top at all. Hopefully that makes sense. You see what I'm saying? So the resistor is deep enough that is not touching this at all. That was my goal. Alright? So let me put the screw here. The smallest screw is right here. Then I can install the vacuum tube, then a speaker. It's like a puzzle, you have to put this in first, then the vacuum tube, then the speaker, because otherwise it's so hard to do it. There's no way you can do it. Alright, now let's put the vacuum tube. Again, you want to make sure the pins are clean before you're installing them. I already cleaned all of them with rubbing alcohol. So this goes right here. Now the speaker going to be hooked up right here. Then we can test the radio. Hopefully it's going to work after all this type of work. Alright, let's just stop the video here. I need to focus on the speaker. I need to rebuild that speaker, as well as working on radio logo and the cabinet. So stay tuned for upcoming video. At this time, I want to take the opportunity and thank my subscribers with their uplifting comments. You always encourage me to upload more videos, since this is just a hobby of mine. Again, I appreciate you. Enjoy all these videos, and you all have an awesome day. Take care. If you're interested to see more videos like this, feel free to subscribe to my channel, and you will be notified when new video being uploaded. You have a great day.